so that's how you develop the appreciation. And similarly, when you are solving a problem, I would invite you to have always this sort of appreciation, and then whatever question is given to you, to do it based on that, so that, because then you will understand, even if you do some mistake later, okay, you would have that appreciation, and from where you will get a sense check. Okay, using your common sense, you will find out that there is a mistake and you will pick it up. Rather than just closing your eyes and then, like some measurement is given to you, you just close your eyes and just solve it. That's it. But please don't do it like that. Always develop a reference point. If a beam is given to you, just compare it with the room in which you are studying, or even in a room where you are sleeping, or you are whatever, whichever image you can make in your mind. But always compare it with that so that you understand what is going on. Do you understand my point?
Yes, sir.
So that is the first thing. Okay, so now lengths we have established, okay, a reference point. But how can we establish the weights? Okay, how much weight is enough for a beam? Now, that is important to appreciate. Length is very straightforward, but the weight is a bit challenging, because the weight you don't know. You might have visually you can't tell that how much weight that is. Okay, because you might have a very small block and it might be weighing very high, it might be very heavy as compared to a big block. Okay, so the volume visually, so if the volume is not a function of your weight, so then you must have some way to calculate it, work it out, and then establish whether it's heavy or it's lighter. Now, in the case of beams, what do you think? As I told you, I'm repeating that your reference point must be of almost an equal weight, okay, almost approximately of same proportion, let me call it of same proportion as compared to your the weight which is placed on your structure. Because, for example, so what can I have a reference point? Can I have a reference point as a fly? A fly is, very light as compared to, your structure, isn't it?
Yes.
So that reference point doesn't work. So what else can I have a reference point? What do you think? Huh? Yeah, but we are also, as compared to a structure, the weight of a structure, we are also not that much significant.
Is there a vehicle?
Yes, vehicle. Vehicle is a good starting point. Okay, that how much thing is heavy, that can be worked out based on vehicles. How many vehicles we have? Yeah. So, for example, a vehicle, an average vehicle, a small vehicle would weigh, say, would be 1.2 tons, 1.5 tons. 800. But on average, okay. Yeah, so say 1 ton, approximately that is the weight. And then, yes. Yeah, you can use, but how much, what's the weight of elephant? You can't use elephant, because as I'm saying, that you must be able to appreciate the weight. And the best thing, and the closest thing you have, or that thing which always come in front of you daily. Okay, if we were living in a zoo, I would agree. Okay, but unfortunately we are not. Yes. So in the case of cars, all the time we are seeing it. Okay, so that can be a reasonable. Yes. Is that okay? Yes. So for example, if we say 1.2 to 1.3 tons is an average car. Okay, I'm not talking about a big car, too big car. I'm talking about 1.2, 1.3 tons. So then that can be a starting point. Okay, that can be. So for example, if you are given a certain weight, you can always convert it into kgs. Okay, and you can, so if it is 1 ton, so 1 ton is how much? 1000 kg approximately. Yeah, and how many pounds? So around about 2000 pounds. Yeah, so 2200 pounds. Yeah, so 2200 pounds by 1000, 2.2. So around about 2.2 kips. Yeah, so that's how you can work out. I mean, you can imagine how much is 1 kip and how much load has been applied. So I mean, that would avoid you to apply too heavy load on a structure. If you know, like for example, how much is the length of how much length is good enough for taking a certain amount of load, yeah, then you would be able to apply that amount of load on the structure. Okay, so I mean, like, you know, that would stop you from overwhelming a structure. Do you understand my point?
Yes.
So that's how we can develop the appreciation for a structure. Now we have classification of structures. We have got different types of structures. Okay, so I mean, can you tell me what type of structures do we have? We can have a beam, starting from a simple structure. So a simple structure can be a beam, a simple beam which is supported at 2 points. Okay, so it is important that a structure is supported. That is important, because if it's not supported, then what will happen? I mean, it will become unstable, and normally the structures, you want them to be stable. Okay, so the simplest structure, the starting point, the first structure you come across is a beam. Now this beam, and then after this beam, you assemble different beams, and you can get a more complex structure. Then, so a simple horizontal structure is a beam. A simple vertical structure is a column. Okay? And if you join this one and this one, what do you get? A frame structure. And you can give any support to it. Okay? And this is mine. What does this mean? Yeah, but what do I mean by this? No, this is not pin. This means that this is a fixed structure. Okay, so by fixed we mean that we have got this structure and it moves, it always stay at 90 degree. This angle always stay at 90 degree. Okay, so we are talking about elastic structure. Whatever is elastic, that stays the same. That comes back. When you remove the load, it comes back to its original state. So, and that's what you have done in your mass. So we won't go into an inelastic range, but this thing means that it's a portal connection. A portal connection means that it's at 90 degree, and if you move it, it will stay 90 degree. The angle won't become like this. Initially, if it was like this, and it won't become something like this. Do you understand?
Yes,
what do I mean? This is the angle, yeah? And it will always stay like this after deformation. That's what we say. But if it is a pin, if I put a pin on it, so then it can move. So that can be a, but these are the three, and then you keep on assembling your structure. And if you keep on putting more and more frames on it, you get a multi-story building. Okay? So these are simple structures. Then another structure is an axially loaded strut or a tie. Okay, this is another structure. This structure, if you assemble them, okay, if you assemble them, you get a truss. So a truss has got only axially loaded members. What is the difference between these two structures?
The load is
Sorry?
perpendicular loading and
Yeah, and if you have a perpendicular loading, then what effect that has? So you would have shear. So if in this type of structures, you can have a load like this and you can have a load like this also. But this type of structure can take loads in any direction. And how does it resist it? It resists that load via shear forces and bending moments. Okay? So in other words, you can have shear force and bending moments getting generated in this type of structures. Okay? So you will have, and how can you have a bending moment? Whenever your structure, a straight structure, when you apply the load and it becomes a curved structure, that means that bending moment has occurred in the structure. Okay, that's how we can say that this structure. Okay, so internally it has got shear force and bending moment. And in this type of structure, where you have axial load, we assume that there is no shear force and bending moment. The load goes through and through this structure without causing any bending moment or shear force. Okay, for bending moment and shear force, the load has to be applied perpendicular to the structure. Okay, so the axis, so you have got, when you have a perpendicular structure, the load applied perpendicular to the axis of the beam, that is your shear force. That's where you would have bending moments and shear force. And through these bending moments and shear force, the load is transferred to the support. Do you understand my point? How does this load? Look, you apply the load over here. How does it come to the, how do you get the reactions? How do you get the reaction? Through shear force and bending moments. Okay, you get the reactions over here. In this case, what happens? You have got no shear force or bending moment. You have got the axial force flowing through the structure. Okay, and then it develops something like this. So let me write it in red, which means like this is a.
the red is not visible.
Yeah, so I'll get another one.
English comes to me.
Okay, is that okay?
Yes, sir.
Now, so these are different types of structures. Okay, now we have
Sir, column is also same. It is also subjected to axial load.
column. Yeah, column also has got axial load, but there is one thing which is different in column. How is, yes, in column you can have buckling, and if you look, I told you that whenever a structure which is subjected to some loading and it turns into a curvy structure, you always have bending moments and shear forces generating in that. So if the column is straight and you have got load running into it, it's just a strut, nothing else. But if you have a buckling, okay, or in other words, if you have it buckled like this, okay, so this P corresponding to this axis will have moments. This P times this deflection, that gives you moment. So therefore this column will have moments also in it. Do you understand my point? So that's what happens. Now, after this, we have different type of joints in structures. What are the joints? I gave you one example that this is one type of joint where you have got fixed connection. Fixed connection means you apply the load and this connection stays like this. Okay, so you apply the load and it doesn't move.
Yes.
So that is your fixed connection, and the type of or it's called portal connection also. Okay, so that is your fixed connection. In case of pin connection, you can rotate it so it can move. So that is your pin connection. What else? Then in the case of pin connection, you can have external pins or internal pins. What are external pins? What do I mean by external pins and internal pins? Again, this is your pin connection, which is externally. This is called hinge support.
Yes, sir.
So, in other words, if you have a beam, okay, so this is a pin connection, and that's an external pin, okay, and you can have a structure where you might have an internal pin. Okay, so that is an internal pin. So in other words, I've got a structure, okay, and I provide a sort of a pin, a sort of a mechanism where it can freely rotate or it can rock. Okay, so that is an external. So you will see in your in your next semester when you are doing design, over there you would understand, like, you know, how can a designer provide something like this, something like internal pin. Okay, so in your design you will be taught how to have this sort of structures, because for an ordinary person, okay, this everything is just like a beam. But you as a designer, internally, you play with the structure, internal, either reinforcement or either if it's a steel, you provide some sort of connectivity between members so that it behave in a certain way. Do you understand my point?
Yes.
So this sort of things you would be taught in the next semester. But I mean, you can have internal pin or you can have external pin. Okay, so any questions so far? External pin is a hinge support. Okay, so it's just a hinge support which you provide. Okay, and finally you have this sort of connection where you have a roller. So what's the difference between a hinge and a pin? A hinge and a roller support. In roller, as the name suggests, it can roll.
Yes.
Okay, so you can have movement in this direction. And in the case of pin, what can happen?
It can rotate.
It can rotate, but it can't move. Horizontally, the movement is not allowed. Okay? So, and then we have a free end. So for example, if we have a beam like this, so it can be free. This end is completely free. Okay, so this can deflect and it can rotate also.
Yes.
Can you appreciate that this has rotated?
Yes.
Yeah, initially it was straight and now it's become like this one. So it has rotated. Okay, and so that's a free end. Okay? Any question? Okay?
Yes.
So okay. Okay, so the next thing which I would like to do is principle of superposition. Okay, have you heard of principle of superposition?
Yes, sir.
What is that?
Property of waves, sir.
Sorry?
Property of waves.
No. It's not. It's related to structural engineering.
No, sir.
Superposition. You superpose something. You superpose something on another thing. What is that? You superimpose something. The basic theme of superposition is that if you have a structure which is subjected to different loads. Okay, for example, pointed loads. It's subjected to 10, 20, 30 pointed loads. Okay, so the displacement at any point, okay, is equal to sum of the structure, the same structure, subjected to each and every load independently. In other words, like for example, if I have a simply supported beam and it is subjected to concentrated load like this, so I can decompose it into two beams which is subject to this load and another one to that load. That's, do you understand my point?
Yes, sir.
That is superposition. So in other words, it will deflect like this. Okay? So if I am interested in finding out deflection, or what is deflection? Deflection is this vertical distance. This is the profile and this is the vertical distance. Okay, so the vertical distance between the original axis and the deformed axis, that is actually the deflection at certain point. So if you are trying to find out deflection of a midpoint, which is this one, okay, you're trying to find out deflection at this point, so you can have it divided into two structures. The first one having the load applied over here, you find out this deflection, and the second one you find out the same midspan deflection over here. You add them up, you get the total deflection. And the fact that you can apply this principle, okay, is due to this whole principle hinges on theory of elasticity. I mean elasticity. If it's not elastic structure, for example, if it bends and it goes beyond elasticity, then you won't have this thing, you won't be able to add them up linearly. Okay, so that is superposition. So we'll do it in the next class, this one. Okay, so I will bring some models in the next class and I will make you further understand like how these things work. Okay, so any question? Okay, so yeah, thank you very much then. Okay, you can just switch. Thank you.